irregardless of which way we go from here, I have the task of trying to explain to you what is a centimole or what is a milli equivalent. I have chosen to describe to you what a milli equivalent is. Every cation that occurs in the soil will have an atomic weight. That atomic weight is determined by the actual structure of the atom that makes up that element. So we're getting back into some basic chemistry here. In other words, sodium has an atomic weight of 23. Calcium has an atomic weight of 40. Hydrogen has an atomic weight of 1. Well, 1 what? 23 what? 40 what? Well, for the purpose of measurement in a laboratory, we're going to say that these are grams. That's the gram atomic weight of that particular element. The equivalent weight is determined by taking the atomic weight, dividing it by the number of charges that are on that cation. So if we said calcium had an atomic weight of 40, it has 2 positive charges, so 40 divided by 2, the equivalent weight of calcium would be 20. Sodium, which has an atomic weight of 23, only has a charge of +1. Therefore, its atomic weight and its equivalent weight are one and the same. The same would be true for hydrogen. It only has a charge of +1. So the atomic weight is 1. We divide that by 1, so we have a total of 1 gram as the equivalent weight for hydrogen. Now that does not mean that one atom of hydrogen weighs 1 gram and one atom of sodium weighs 23 grams and whatever. But what we're saying is that 1 gram of hydrogen is equivalent to 23 grams of sodium and 20 grams of calcium. Now, when expressing cation exchange capacity of the soil, we don't use equivalent weights, we use milli equivalents. The prefix milli, M-I-L-L-I, in the metric system means 1/1000th. So a milli equivalent weight is 1/1000th of the equivalent weight. In other words, calcium has an equivalent weight of 20. We divide that by 1,000. We get 0.02 grams as the milli equivalent weight of calcium. Hydrogen, which has a weight of 1, equivalent weight of 1 gram, divided by 1,000, will give us 0.001 grams for the equivalent weight of hydrogen. The next statement that I'm going to make is one that I want you to write down and think about. And that is that 0.02 grams of calcium is equivalent to 0.001 grams of hydrogen. That is to say that 1 milli equivalent weight of any 2 cations will have the same number of cations in that weight. They don't weigh the same, but they have the same number of actual cations within that weight. And since we're talking about charges here, and it's based on charges, we're also saying that 1 milli equivalent of cation exchange capacity in a soil can hold 1 milli equivalent weight of any exchangeable cation. I'll say that one more time. 1 milli equivalent weight, or 1 milli equivalent of cation exchange capacity in a soil can hold 1 milli equivalent weight of any exchangeable cation, irregardless of what that cation is. You will need to have a basic knowledge and understanding of this when you do the laboratory associated with this unit. The laboratory associated with this unit is called cation exchange and soil acidity. In that lab, you will be asked to do calculations on milli equivalent weights and cation exchange capacity of soils. There will be further explanation as a part of that laboratory on how to do these calculations. So remember, when you look at this chapter, this reading assignment in the textbook, and you read the discussion on cation exchange capacity of soils, that the units on that cation exchange capacity is listed for you in terms of centimoles per kilogram. These are numerically equal to the milli equivalents per 100 grams of soil. Obviously, the advantage of using centimoles per kilogram has to do with expressing cation exchange capacity on larger volumes of soil under field conditions versus cation exchange capacity on smaller samples being analyzed in a laboratory.